Good evening and welcome to the BS and Beer Show. I'm Travis Brungard here in Prairie Village, Kansas. Tonight I'm going to be drinking a high PA, which my buddy Dan just gave me this afternoon. It's an orange tangerine IPA, and it has Slimer from the Ghostbusters movie on it. No tie-in with our topic tonight, just a funny looking can. It was a long day, so I'm a little off. Bear with me. Here we go. So tonight's topic is foam glass aggregates, its products and applications. I've already introduced myself, so I can skip that, and we'll go straight into talking about BS and Beer, which is an independent grassroots movement to share building science knowledge through local meetup groups and this, our Zoom platform. The brew crew and our guests volunteer our time each week to bring you what we hope is a fun and informative discussion. I want to thank Fine Home Building and Green Building Advisor, our partners in this endeavor. If you would like to find the chat box icon at the bottom of your screen, you can post your questions and comments there. You'll want to be sure and click all panelists and attendees or everyone. Otherwise, Zoom tends to default back to panelists only, which means only a few of us can see your comments and we may not get to them. Fine Home Building will send out a Zoom reminder each week. So if you want to receive those as well as other information, join our mailing list at thebsandbeershow.com or check out the weekly post at Green Building Advisor that goes up on Sunday mornings. That's where I always find out about it. The video recording of tonight's show will be available at Green Building Advisor, and all past shows can be found on YouTube through a link at thebsandbeershow.com. An audio-only version of the BS and Beer Show is available on Spotify and Apple Podcasts. We have a bunch of links that Mike will add to the chat box. I will mention them here. First off, you should join Fine Home Building for their first Pro Talk Live event on Wednesday, January 12th at 9 a.m. at Red on Salmon in Portland, Oregon, hosted by senior editor and Pro Talk podcast host Patrick McComb. Guests will hear from the industry pros Tim and Brian Euler, Josh Salinger, and Lindsay Shack in this one-day only expo. The link's going to be in the chat. I wish I could go to that. That's going to be so good. NAHB's International Builders Show is February 8th, 9th, and 10th in Orlando. The Brew Crew will host a live BS and Beer Show in the afternoon of each day. Efficiency Vermont's Better Buildings Conference is February 2nd and 3rd in Burlington, Vermont. You'll want to register before December 15th to get a discount. Which was yesterday. So too late, you blew it, you missed your discount, you're paying full price, but it's so worth it. Just go. Nessie's Building Energy Boston Conference is February 28th through March 1st in Boston. And the Passive House Network's Introduction to Passive House Trades course, which is a 4-hour on-demand format training course for contractors and tradespeople working on passive house residential and commercial building and construction. This course is now live and accessible anytime, and the cost is $156. And all those links will be in the chat, courtesy of our good friend and partner, Mike Maines. Thank you, Mike. And with that, hello, Emily.
Hello, welcome everyone. As you know, for the month of December, I've been doing a wind down. Tonight we're having Farmhouse Red Blend, and it is actually my wine night. And so I'm not cheating tonight and drinking wine for BS and Beer and then posting it on a different day, which is my wine night. Today is actually my night for the wind down with our family. So cheers to everyone on that. I have the pleasure of introducing our guests. So this is a topic that I've been super interested in. So I'm glad to have all of you on here for our last show for 2021. So we have Archie. He's the founder and CEO of Aggregates. He has over 25 years of international experience in the geotechnical market and is an adjunct professor at Temple University in the Graduate Engineering School. Archie, anything else we missed? Tell us what you're drinking. Thanks for joining us.
Sure. I went local tonight. I have a Victory Brewing Hop Hazer IPA. So, and real pleasure to be here tonight. Background has been in geotechnical, civil construction, design, build for about 25 years, and looking forward to the program tonight. Thanks.
Awesome. Thanks for joining us. We also have Teresa. She's the technical director for Aggregates, where she oversees research and development activities, technical documentation, engineering support, quality control program, and education and outreach efforts. Thanks, Teresa, for joining us. What are you drinking and anything we missed?
No, thank you for having me. Tonight I'm drinking a beer by, well, you can't see it, but Neshaminy Creek Brewing Company. Called Citrus Shape of Haze to Come, and they describe it as a double IPA with grapefruit and orange. So I'm very much looking forward to it. No, my background as well is geotechnical engineering. And yeah, I'm thrilled for the invitation to be here with all of you tonight and also looking forward to it.
Awesome. So we have Ken. Ken is the COO of Glavel. He is also the senior leader at IBM Microelectronics and Keurig Green Mountain, where he has driven facility and production startups, as well as expansion of new and existing products. Ken, welcome. What are you drinking? What'd we miss?
Oh, you're on mute.
Yeah,
There we
sorry,
go.
had to unmute. Well, thank you. Great to be here. I am drinking a Burlington Beer Company beer. It's a New England Pale Ale called Noble Bright. New to me, but Burlington Beer Company is there's a lot of great craft beers in Vermont, but Burlington Beer is one of the really good ones. They also happen to have really cool cans, in my opinion. I'll let you know how it goes as we go on to the my background actually is a little bit different in that my expertise comes primarily from process and manufacturing engineering endeavors. I think you said leader at IBM and Keurig. Those are former roles, but I spent 25 years making semiconductors here in Vermont, and then was the director of equipment engineering at Keurig. So really cool to be in this world now, and as we'll talk about in this show, been active for the last few months in setting up our first manufacturing facility, which is up here in Vermont. So it's been really cool to be kind of back in the world of process engineering and very deep in sort of starting up new equipment on a new technology, at least new to us. So been very exciting, and we're excited to be on the doorstep of production in the next few weeks.
Awesome. Very cool. And last but not least is Rob. He is the CEO of Glavel and a certified passive house consultant. For the past 10 years, he's focused on renewable energy startups, bringing leading edge technologies to the market at Draker Laboratories and thermal storage solutions. And Rob has a presentation for us. So introduce yourself, Rob. What we miss? What are you drinking? And then you are welcome to kick us off.
Awesome. Well, thank you so much for that introduction. And the Farmhouse Red, we survived COVID on cases of Farmhouse Red, so I wouldn't be here if it wasn't for Farmhouse Red. And I am drinking Burlington tap water out of a repurposed wine bottle. So I've got that going for me.
Very cool. This is my first time having it, so I'll let you know how it is.
Oh,
that was a
so
great
good.
endorsement. I'm going to enjoy this.
Yeah, it's awesome. So I'm going to go ahead and share my screen, and I'm going to remember to click on share sound and optimize video, because I forgot that the last time Archie and I presented. And I was checking to see if we were going to have a white Christmas. And here we go. So thanks again for having us at the BS and Beer. I'm going to start us off with a reminder that our amazing high performance buildings and energy efficient buildings usually start with burying a ton of petroleum and nasty chemicals in the form of rigid foam board. And this is a lovely picture of what foam board looks like from a retrofit, and actually in Japan. Our partner, Walter Frank from Glypor, sent us these pictures and dubbed it Ants in Paradise. So we have to imagine all of these buildings that we're building, what is the real performance over time when rigid foam board becomes home to insects or rodents or degrades because of high water table, that sort of thing. And we're really excited to be part of bringing foam glass gravel to market here in North America. It's an amazing product with wonderful properties like water resistant, rot resistant, fire resistant without nasty chemicals. Our products are closed cell, they're load bearing, very lightweight, and thermally insulating. So an absolutely phenomenal product for high efficiency buildings for sure. Just want to take a step back and talk a little bit about the history of foam glass. So foam glass gravel has been on the market in Europe for over 25 years. It starts its life as recycled glass, and that glass is cleaned anywhere from less than 1% non-glass to about 3% non-glass. Practitioners all over Europe have varying degrees to which they clean their glass to produce the feedstock, which is glass powder. So the glass is ground into a fine powder, and then a foaming agent is added to that powder and then run through a about 25-meter long kiln at around 900 degrees Celsius. And the product actually, just like it says, foams up from about 2 centimeters to about 8 centimeters. There is a spectrum in terms of the foaming agents that can be used to achieve this process, and a fairly wide variety of products that can be produced. So it's not a monolithic product by any stretch of the imagination. So there's R values that can get up into sort of the R 1.8 per inch and as low as R 1.7 per inch. So it's really important to think about this product in terms of a spectrum of what the product can be and do. In Europe, about half the sales are in infrastructure for roadbeds, embankments, tunnels, pipe insulation, and then half the sales go into buildings. So subslab insulation and drainage, green roofs, and frost protection. I love showing this image on my right of a report done by the EPA back in 1977, recommending that we transform our waste glass into foam glass. So it only took about 40 years for us to get around to do it, which is awesome. A little bit, really quick history of Glavel. I was introduced to the product by Floris from 475 at the Passive House Institute conference in Darmstadt in 2016. He and I endeavored to try to bring foam glass production to North America through 2017, touring multiple plants in Europe and getting the lay of the land and that spectrum that I described in terms of various ways of producing the product. Some very clean and I would say kind of high tech and high quality product orientation, and some not so clean. So it was great to sort of see what folks in Europe were doing. In 2018, we committed to produce the product in Vermont. From 2019 to 2021, we've been fortunate to import and sell foam glass from our partner, Glypor. And in 2022, we will be producing product in Vermont. This will give you a quick sense of what it looks like to produce foam glass. Hope that's not too loud. Had a sort of an abrupt end because I think that Euro music kind of gets to everybody. Oh, there's more of it. Oh, so this is a quick example of a typical installation of foam glass as a replacement for the 3/8 drainage layer as well as foam board. And the amazing property of foam glass is that you're achieving both the drainage layer and the insulative layer with one product. We live in incredibly dynamic times with supply chain issues, and foam board has become a very costly product on the market. So folks are really looking for an alternative, which is great for us. It's incredibly versatile here in this detail that our friends at Webster Design did for us. You can see that a radon piping is placed within the product. Very easy to use, very forgiving if you need to go back and install plumbing in the product and then recompact the product on top of that change. We believe and have seen from our customers testifying that the product on an installed basis, even before the recent price increases of foam, was less than the cost of installing the traditional product. So you get a high performance product without the premium, which is a phenomenal story. This was our first installation here in Burlington, Vermont at 167 North Winooski Avenue back in June of 2018. Back then we were partnered with, it was myself and Flores from 475, and we were importing from actually an Austrian company, GeoCell at the time. And in the spirit of BS forums that we had here in Vermont, sharing not just the successes, but the challenges, this was a really challenging install. It was an incredibly tight urban site, and removal of the material in order to install the product was a huge challenge. We learned a lot. This was an interfit project with a shared wall that you can see that needed to be protected. So lots and lots of learning on this project. The architect was Arthur Chuckman from Duncan Wazinski here in Vermont. And he, early on in 2018, was very concerned about the embodied carbon in the materials that he was using on his own project. One of the things he challenged us was to deal with the bags that the product came in. So after he had installed it, he called me up and said, "Hey, Rob, what should I do with these bags?" And I drove to site and shoved them into my Outback and was able to bring them down to Recycle North, and they were repurposed. And there was born our commitment to make sure that our bags don't end up in landfill. So we will have a process by which that we work with our customers to ensure that the packaging that our product is delivered in doesn't end up in landfills. These are a few projects that we've done over the last couple of years. This project here, if my pointer is working, was a Bensonwood home. We were really excited to be partnered with them to deliver the insulation below their slab. This was a project in Vermont where they were committed to reducing the embodied carbon, and one of the strategy was to reduce the amount of concrete used in the stem wall. And this is a really exciting project in Virginia. This was the Capital One headquarters in Virginia, where we're fortunate that our partner Glypor has a range of products on the market. That this product actually was a much lighter product that was used with a less compressive strength for a green roof application. So green roof designers really appreciate a range of product density and weight. These are our friends out in California, Bishop Passive House. Highly recommend checking out their complete series that they did with this project, soup to nuts with all kinds of passive house measures. So highly recommend checking out the whole series, but this is a little vignette they did on Glavel. If I can get it to play.
Hey, it's Andy Pease, Inbalance Green Consulting. I'm here again at the Los Robles site. We're talking with Mike Horgan about the foundation and the insulation and an awesome material called Glavel. And the things that I'm excited about for this part is that, one, we just want to talk about the importance of having insulation under the slab for this project, but also a really an important way that we're trying to use less foam and looking for a solution to be able to insulate, use less foam, and even save some money. All right, so Mike, let's talk about what is the product first? What is this thing that we're talking about?
It's called Glavel. This is it's a recycled glass, 100% recycled glass aggregate. It almost feels like pumice, like a sponge.
Like super light.
Yeah, it's really light. Structural engineers loved this stuff when they got to see it the first time. So it comes in about a 3-inch rock, 100% recycled glass, and it comes in 700-pound bags, Hannah, right? And we just unloaded the bags off a truck. We dumped them inside the slab. 2 of us spread almost the entire slab in half a day, compacted it all in half a day. So it went down really quickly. It's very light. We moved it around with a push broom and a rake. This provided a few advantages to us. We needed to have an insulated slab in this house in order to pass through PHPP, the Passive House Planning Package. It's also really advantageous to have an insulated slab in this area because we actually it's fairly cool here at night. I mean, it was in the 30s, high 30s last night. So floors are really cold in the morning, and this creates a great amount of comfort. So what this does is it gives us a thermal break in between the ground and the slab. So the little air bubbles inside the gravel will cause temperatures to stop moving from the ground into the slab and creating that cold floor space. Sometimes when you get new products on the market, they come with a bit of a cost measure, a bit of a learning curve. The learning curve for this was basically non-existent. We brought the concrete crew out here and they learned how to do it 100 times faster than we learned how to do it. And then cost-wise, we had planned on $2,500 worth of gravel stone aggregate and another $1,500 worth of a rigid foam insulation that Hannah and I were going to put down ourselves. So this actually shipped to us. We shared a shipping container with 3 other projects in California. This was $3,100 delivered. So we got our aggregate and our insulation, and our install time was, I think, less than what putting an aggregate stone down would be. So fed a bunch of birds with one scone. Yeah.
Excellent, thanks.
Cool.
That's so awesome. So come on, there we go. So just really quickly wanted to talk about the versatility in terms of cold climates like we have here in Vermont, and the ability to use gravel as an insulator on the outside of a frost wall, in addition to under the slab. We also are fortunate because of our partnership with Glidepore, we will have available, once shipping containers become a bit more reasonable, a board product. So it still is foam glass, so it's still made from 100% recycled material, but it's in a board form. And we think it's a great application to put that board on the outside of a frost wall. So in this detail, you're seeing the foam glass gravel underneath the footing, and then the break here using a board product of foam glass. And Glidepore does sell a system, a foundation system they refer to as RDS, which is a long, complicated German word, but we just call it the foundation system that I can show you.
Buildings without floor insulation no longer fulfill the standards currently required by the Energy Saving Ordinance. However, this requires a specialized insulation the builder can fully rely on. Glidepore cellular glass. There is no other safe and ecological insulation that better meets these requirements. Produced from pure recycled glass, Glidepore cellular glass is available in board form and loose fill material called cellular glass gravel. The Glidepore Border Insulation Formwork System, or RDS for short, is the perfect combination of both products. Ecologically friendly, pressure resistant, waterproof and long-lasting, frost consistent, rodent and insect resistant, non-combustible, easy handling, and suitable for construction sites. Below the line, absolutely safe, sustainable, and economical. Save time and money even during preparations. The RDS system combines functions, eliminating work steps required in the past. Complex classic formwork is no longer necessary to pour the floor slab. Both common insulation panels and the granular subbase are eliminated. The horizontal frost shield is also no longer necessary. Another benefit, reduced excavation depth and surface area. The RDS system is delivered in common packaging units. The border insulation formwork can be placed quickly and easily into the mortar bed excavated to the frost line. The modules prefabricated in the factory are moisture barrier floor slab formwork and top insulation for the floor slab in a single unit. It is not necessary to support the border insulation formwork when pouring the floor slab. A geotextile separates the soil from the cellular glass gravel. This is distributed to the bottom edge of the concrete floor slab and compacted with a lightweight vibrating plate. A PE foil prevents the concrete from penetrating the insulation. The outside of the RDS can be sealed and filled directly after concrete is poured. your planner can decide whether drainage is required. Other connection work can then be continued with no problems. This is a significant advantage, especially for prefabricated homes. The system creates a seal, prevents moisture penetration from the sides, and guarantees dry, consistent floor insulation. Glapor's Border Insulation Formwork, RDS. Glapor, extremely durable and safe. Glapor, the sustainable ecological solution.
There we go. So again, we're really fortunate to be partnered with the folks at Glapor. Walter was at the forefront of producing boards back in 2007. And we're just really excited to introduce not only the foam glass, but also the board form of foam glass. I thought it'd be really interesting to showcase installation of foam glass that folks that are looking to really minimize their embodied carbon. And one way of doing that is to, in a retrofit scenario, not re-pour a slab, but rather lay down a wood flooring on top of foam glass. We've had a few requests for this, and I sort of pilfered these images from the installation guide that Glapor has for folks that want to try to really reduce their embodied carbon, which kind of leads me to our next subject, which is how do we take a product that has a storied history in Europe and bring it into the next 25 years? It's been around for 25 years in Europe, and what does the future look like? It had a great run in terms of the fact that it was a upcycled material from waste glass that had little or no value. And what we're committed to doing is, in taking it into the next 25 years, are doing things like a commitment around social justice weaved into who and what we are. So we are committed to helping break the cycle of incarceration by hiring formerly incarcerated individuals. We're committed to creating an environment that is welcoming and safe for folks from the LGBT community, where they can be their true and authentic selves. We're also working with folks at Vermont Works that are helping women in transition develop new career paths. So there's a deep commitment around social justice in who and what we are. And low embodied carbon building materials. So it's not just the foam glass, but it's also other low embodied carbon solutions. That starts with foam glass is critically important to what we're trying to achieve. Most of you may already have some familiarity with embodied carbon. Our friend Stacy Smedley at the Building Transparency Institute created this lovely gift that kind of demonstrates what is involved in terms of determining the embodied carbon of materials. It includes how the materials are manufactured, the transportation of the materials, and the installation on site, and then whole life at the end of life of the product as well. And realizing that in certain areas in North America where energy may have a very low embodied carbon, like we have here in Vermont, where our electrons are virtually carbon-free, the embodied carbon in the materials that we use here in Vermont is really important to help mitigate the issues around carbon and the climate. I did touch base with Ken Levinson from the NEPHN network this week, and he confirmed that the EC3 tool, which is the building transparency tool that helps aggregate the embodied carbon information from EPD reports, will be interfacing with PHPP. So if you're using that as a tool for your energy efficient buildings, being able to integrate the embodied carbon data is going to be phenomenal to planning and ensuring that not only are we producing low demand buildings, but also considering the carbon that goes into those buildings. For just illustration purposes, reminding folks that, not surprising, polystyrene products have a very high embodied carbon and foam glass has a relatively low embodied carbon. These numbers were taken from the UK and illustrate foam glass that was produced with fossil fuels and burning natural gas. So foam glass kilns can either burn natural gas or be electric heated with resistance heaters. We chose from the start to use resistance heating. So the kilns at our plant in Vermont and all future plants will be electric kilns, which allows us to deliver an even lower embodied carbon material. I'm sure you're aware that electrification of manufacturing is a key component to helping us achieve our carbon goals and help mitigate the effects of climate change. Here's a little snapshot. These are a little dated, but this is the plant in Vermont that will be operational next month. And just want to close off by saying that at Glavel, we're committed to producing the highest quality building materials and providing our customers with comprehensive low carbon solutions. Dun, dun, dun. And with that, I hand it off to Archie and team.
All right. Emily, can we just go ahead and get right into our slides? All right, awesome. Okay, here we go. Well, thank you, everyone. And Rob, thank you for your presentation as well. So as we were introduced, I'm Teresa Laux. I'm our technical lead here at Aero, and Archie is also a panelist today. He's our CEO. We have a very similar slide to what Rob showed as one of his first slides, actually. And this slide is just telling you all of the attributes about foamed glass. And we kind of coined the term UL, FGA, and the UL stands for ultra lightweight. And the reason for that moniker is to really distinguish ourselves from some of the more traditional lightweight aggregates that have been out there and available on the marketplace for many, many decades here in the US. So the foam glass aggregate that we manufacture, we have a maximum dry unit weight of 15 pounds per cubic foot. And those, traditional lightweight aggregates, they're closer to 60 pounds per cubic foot. And then, as you know, our mineral aggregates are, 100 PCF or so up to 120 PCF for soils. So our foamed glass aggregate is a good insulator. It has a very high friction angle. And as a geotechnical engineer, one of the way that we describe the strength of materials, of our soil and aggregate materials, is by the friction angle. So you see friction angles very typically in the mid 50 degrees, which is generally very high. We're frost resistant and act as a capillary break, and we're frost resistant because of the closed cell nature of our standard closed cell foam glass that we make. The capillary break aspects is really just due to the particle size, right? So our average particle size is right around 1.5 inches or so. And so the layer of foam glass aggregate won't draw water up into your slab, right? It'll prevent that. Also, with that high porosity, we're going to be very free draining, allowing water to pass in and out of the layer. We're a good load bearing layer, and then we can also be very useful in seismic designs. And so in seismic areas where you have to be concerned about earthquakes causing movement of the ground, and that ground applying loads on your structures, typically, foam glass aggregate is very useful just in the fact that you're reducing the mass of what's going to be shaking during the seismic event. This photo is just an aerial photograph of our plant. Our Eddystone plant is just outside of Philadelphia in Pennsylvania. So you can see kind of what our operations look like. All of our manufacturing and glass processing happens under roof inside of that warehouse building that you see there. And then obviously all of our product gets stored outside. And to just give you a better idea of what Aero's been up to, we established the Eddystone, Pennsylvania plant. I believe we bought the building in 2016 and manufacturing operations commenced in 2017. So there we have the Eddystone plant. Early in 2022, we are going to be opening a plant in Florida in Dunellen. And then later in 2022, we will be opening a plant out in California in Modesto. And so I think Archie has some other news to share, but I'll let him share that later on after we're finished here. All right, so similarly to Glavel, right, all of the glass that we're using is recycled glass, right? It comes from curbside collection programs, and generally everything that we're using is being diverted from landfill, right? This is the glass that generally can't be further recycled into new glass bottles or jars. And I do like to share this data. Unfortunately, this is a little bit of a disappointing slide, I think, for many of us, certainly kind of forward-thinking people. And, you know, unfortunately, the reality is that here in the United States, we are only recycling about 31% of the glass containers that we are using, you know, each year. If we look at total glass, that number decreases even further to only be about 25%, right? And if you've grown up and thought, you know, your whole life that glass is this endlessly renewable resource that can be, you know, made into a new glass bottle or jar every day, that's true. But unfortunately, here in the US, we actually do a pretty terrible job of doing that. All right, so, you know, here at Aero and certainly Glavel, you know, when they get started, we're hopefully going to be increasing this, you know, recycled percentage for total glass here. All right, so these photos just kind of depict some of our stages in our manufacturing process. Here at Aero, we are vertically integrated. And so what that means is that we are able to clean all of our glass that comes to us, number one. And number two, we're also able to mill that glass ourselves. So that's what you see kind of shown in the first two photographs here. You know, cleaning the glass is very important because a lot of the single stream collection processes create a you know, a glass product that has a lot of paper and plastic in it, a little bit of metals and ceramics as well. But, you know, we have to start with generally as much glass as we can. So our first step is always cleaning the glass. And then we have to take it down in size, right? So it's coming to us in cullet form. So generally what that means is it's less than an inch or so in particle size. And we need to take it down to a glass powder. And so that powder, you know, I like to describe it as kind of the all-purpose flour that you would bake with. Even though we start with mixed color glass cullet, when you mill it very fine, the glass can't reflect the light in the same way. And so we're left with an off-white powder that is very reminiscent of that all-purpose flour you bake with. And then we're able to use dry foaming agents. So you know, you might see the distinguishing factors, dry versus wet process. We do all dry process at Aero, but the manufacturing process is very similar to what was described in the videos that Rob showed. You're basically mixing glass powder with foaming agent and then letting it travel through a kiln where the temperatures get up to, you know, 900 to 1,000 degrees Celsius. Yeah. All right, so our focus when we got Aero started was actually very much focused on infrastructure, right? And dry process material does tend to be a little bit heavier in terms of unit weight, right? I mentioned our maximum dry unit weight is about 15 pounds per cubic foot. And as a result of that, you get some very strong product. And so, you know, again, our focus to get started was certainly infrastructure where we can be used underneath of, you know, roadways to build up embankments, behind bridge abutments, you know, all of those sorts of things where, you know, compressive strength is actually very, very important, right? You want to make sure that your pavement structures hold up over the whatever design life you have. It could be 20 years, it could be 30 years. You know, it all depends. So we actually commenced a manufacturer's quality control program that I oversee. And, you know, to date, I think we've done over 5,000 of these compressive strength tests that you see being run in the photograph here on the right. But, you know, a lot of these agencies that are involved in infrastructure, they, you know, find this to be a very important aspect of our manufacturing, right? So you can see kind of the range of things that we've done. compressive strength, all of the durability tests, pull out tests to be used in mechanically stabilized earth systems. Certainly direct shear, where we're able to characterize that friction angle, is very important. And then as we kind of expanded the applications where we're used, we've done thermal conductivity testing, permeability testing, those sorts of things. All right, so we like to show this slide just to kind of orient everybody, to let you all know that there are different types of foamed glass aggregate that are out there and available, right? And so both Rob at Glavel and here at Aero, our standard products are closed cell foamed glass aggregates. So what that means is generally that they're going to be low absorbing materials, right? You have these entrained air bubbles inside of the particles that are generally completely encapsulated by glass. And so they don't absorb water, right? You're not going to get very high increases in unit weights. You're going to have good durability, meaning that the materials won't absorb the water and then freeze and then crack up or anything like that. And I did mention, right, we make our closed cell product via the dry process, and Glavel is, I believe, making their material via a wet process. So we just have different foaming agents, as part of our production. We at Aero also have the ability to make open cell foamed glass aggregate. And here, what we're doing is we're just switching out that dry foaming agent that we're using. And the product that we get for open cell material has a void structure that is much more interconnected, right? So we have voids interior to the particle that allow water to be absorbed. And so the applications for open cell, as you can imagine, are things where this would be good, right? Things related to agriculture and filtration. And I do have another slide where I'll tell you about some more. All right, so as part of our company, we've defined these 3 pillars to kind of differentiate our product lines that we have. And so under Aero Aggregates, right, we've kind of focused all of our infrastructure work here under Aero Aggregates. So this is obviously going to be the closed cell, material made via the dry process. If you see the trade name Growstone, that is our branding for our open cell material, where this material can be used as a soil aerator, also just for moisture retention in growing media. And then lastly, we've established the Aero Light pillar. And this is a combination of both open and closed cell foam glass. Separate products, but applications for open and closed cell foam glass aggregate. And I'll tell you about some of them coming up. All right, so this slide is showing you some of our applications where we would recommend closed cell foam glass to be used. So, a lot of our focus to date has been in infrastructure work, and a lot under slab as well, not just for insulation, but also just for general load balancing, or trying to reduce, the total weight of the structure on, say, a soft underlying layer. We also have applications in resiliency where you're trying to raise grades, generally adjacent to waterways that are going to potentially flood during, storm events. And then the last 2 areas here where we would certainly recommend the closed cell is for concrete blocks, right? So substituting foam glass aggregate for those traditional aggregates that are used in your cement blocks. And then using foam glass as an aggregate in lightweight concrete mixes. Okay, so some of these applications are patent pending. I think we have some patent pending in resiliency and the concrete blocks and lightweight concrete. And then this next slide is just showing you some of the applications for open cell foam glass. And here we have applications for green roof and also blue roof systems. But here again, you're just trying to support vegetation. The open cell is great because it does retain that moisture. So, you're not so dependent on precipitation, right? You can store some of that water, and then when the plants need it, they can access it. We have a consumer brand that we will be rolling out here. So Growstone in these larger 1.5 cubic yard bags. just as a aerator and moisture retention material for agriculture uses, right? All types, water and air filtration and filter media, and then floating water treatment systems. And again, some of these applications are also patented or patent pending. All right, so I wanted to finish by just showing you some of the projects that we've been used on to date. All right, so the first is this passive house on Cape Cod out in Harwichport. And I wanted to just show this profile just to show you, where they're utilizing the foam glass aggregate as insulation and the capillary break, right? So you can see it certainly under the slabs, but also up against the basement walls, right? And so, very frequently, it's a great material to be using in passive house or passive building construction because it does have that, very high insulation value and just in general is a green building product. So here's just a couple photos from that passive house construction. The contractors find foam glass aggregate very easy to use. As Rob mentioned, the bags are fairly light, right? Easy to move around with the construction equipment that they already plan to have on site. And you could have bags with this spout on it like you see, or not, and you could just be cutting the bags open. Here's another project. This one's in Boston in Roxbury. And this is a 7-story multifamily building, right? It is being built to passive house standards in the city of Boston. And you might have seen it on social media. It's a mass timber structure, a pretty unique one, but foam glass is being used here all over the project site. Here's a project a little closer to home for us. This is a new hotel that was being constructed in Camden, New Jersey. So Camden is just right across the river from Philadelphia. The foam glass is being used here dual purposes, really, right? To raise the grade over very soft soils right adjacent to the river. So I believe that the existing grade to the proposed grade was a difference of about 3 to 4 feet. And then, they're using it as insulation and drainage as well. All right, so just a couple of photos from the construction here. And then some of my last photos here is just to show you about how foam glass aggregate can be used to just optimize structural elements. So here we're focusing on retaining walls, right? And one of the design aspects in retaining walls is you need to be able to quantify the lateral earth pressures that are being applied to that wall, right? And in general, the two properties that inform this quantity of pressure is the unit weight of the material and the friction angle of the material. So if you're able to replace traditional soil with, a material that's about, anywhere from say a 1/6 to an 1/8 of the unit weight, and then increase the friction angle from say 35 degrees to 50 degrees, right? You're vastly reducing the lateral earth pressures that are being applied to the wall. And so now you can start to skinny up the structure itself, right? Reduce the amount of concrete that you're going to use, reduce the amount of steel that you're using for reinforcing. All right, so here we just have a project in Cambridge in Massachusetts where, again, optimizing these structural elements by reducing the lateral earth pressures. And then this is a medical center out in Lancaster, Pennsylvania, where the same idea, you're using this wedge of soil behind the wall in order to minimize our loads on the actual wall itself. Right, and then we wanted to finish up by just showing you a couple photos from one of our infrastructure projects. So this is one of our largest projects to date. This is up in Providence for RIDOT, right? This is the new Route 6 and 10 interchange, again, just outside of Providence, kind of on the Beltway outside. And, here the foam glass is being used as bridge abutment and ramp backfill for one of these new flyover ramps, actually 2 ramps associated with this project. And so the total thickness of foam glass that was used, it goes up to about 36 feet at the actual abutment, right? So it kind of ramps up from, from where the ramp starts up to the abutment. And so this is, closed cell dry process material is great for this type of application where you do need kind of the higher compressive strengths, and the DOTs tend to be worried about this. And the photo that you see on the screen is actually only when the ramp was about half of the height. So the abutment construction is only about half as tall as the 36 feet. And the reason why they're using the lightweight fill here is because there was an underlying existing utility that the utility company told the DOT that they couldn't surcharge. All right, so they were able to excavate some of those existing heavier soils and then fill that area and the additional height of the ramp with foamed glass aggregate. And here's just a nice photo of the finished ramp. It's this ramp here in the background, and they're putting the steel for the flyover now. All right, so with that, I conclude my slides, and yeah, I welcome the conversation that we're going to have.
Yeah, thank you, both of you, for really kind of elaborating on all the cool things that foam glass is. There are a ton of comments. Some of you were answering in the chat box. Hopefully Mike has captured the ones that got answered in the chat box that should still be answered on video. I mean, at this point, I don't even know if we'll get through all the questions. So I really appreciate you showing practical applications and details and the different materials that you make and all of that. And so I think I'll just start at the top, which I know at least some of you had answered in the chat box, which personally, Hans wanted to know if it was available in Maine. So if you guys want to start there.
Emily,
Absolutely.
we're actually shipping a project right now in Bangor, Maine, so materials on site, a couple thousand yards. It's going in part of a waterfront project. So we've been shipping up to Maine for the last 3 years.
Yeah, and we did a project in Maine in 2020, and we've got some phenomenal logistics partners to deliver to Maine from Vermont as well.
Yeah, and I think you guys shared to Teresa, at least in your slides too, as well. You're going to be coming to other parts of the country too, which is awesome, so that it'll be available, not just on the East Coast, which is cool. But one of the questions I think that relates to that, which is, I didn't find it. I don't know how to pronounce that, but somebody else also uses recycled glass and they're experiencing material shortages. You said we only really recycle about 30%. What's plan B if you guys can't get enough material for the demand, right? Because if this catches on and people really start using it and they're using it everywhere, like what's the goal to either get people to actually recycle, or what else can you use if you can't get recycled glass? Like what's plan B?
So Emily, I'll take a shot at that. I think when people talk about using recycled glass, whether it's for fiberglass or for containers, the shortages that exist out there are very clean, color sorted cullet, which is what these people need to put in their process. One of the benefits of foam glass is we can take smaller pieces that are color mixed that basically nobody else wants. And that's what's really neat about this process. So even if you've got a great recycler that's doing fiberglass and they're using all recycled, they have a huge portion of what they do that they cannot use. And that material that they can't use always goes to landfill. And our process has been to take that and divert it and turn it into foam glass. So those limitations for recycled glass that you hear about are usually very specific, clean, color sorted glass. But when we get down to the low end of the spectrum that nobody wants, that's kind of what's really neat about this process. That's what works fine for us.
Yeah, and that's what's great to work with recyclers is the CapEx to install that optical sorting to get to those diverting by color if it isn't sorted already. We're a great partner for them.
To be perfectly honest, I'm not sure I would care if there was a rainbow under my slab either, right? I mean, like, I mean, it's great. You guys crush it down, so clearly it turns into fine powder that doesn't have any color. But the reality is, I mean, if it's under the slab or under the ground or under the ramp,
So Emily, I can give you a quick anecdote to that. Prior to Aero, Teresa and I worked together at a construction company, and we did a lot of design build work. And we started looking at glass cullet as a drainage layer or just as a granular material in place of aggregate as the cullet. And what we found was on a lot of the high-end developments we were working on, they wouldn't use it for one reason: it looked like trash. And that's I mean, job after job, it looks like trash, you can't use it. So when we learned about foam glass back in 2013 and we first started, we're like, this is everything that we've talked about. And the benefit is it doesn't look like trash. It looks like an aggregate, as you saw from the pictures. And just that little difference in mindset has really had a big impact for us using recycled glass on projects.
Yeah, that's really cool. There are also plenty of questions about all kinds of other things, but one of them was about inhaling the foam glass dust. Like how's the dust, impact both people working at your factories, right? Or there are people on site kind of installing it. Like what you talked about what it's made of, but what's the impact of that? There's so much in the construction industry with working with different materials and cutting things and the dust and, the impact on people physically.
I think we should let Ken talk about amorphous glass because Ken hasn't had a chance to talk yet.
Yeah, Ken, don't be silent. Jump in.
He's just drinking beer.
It is a common question because it's commonly known that silica is a carcinogen. The key here is that bottle glass is an amorphous product. It's amorphous silicon dioxide, meaning it doesn't have the same crystal and structure as a crystal glass. The carcinogen that people talk about as a dust is silica, crystalline silica glass. So the products that we're making, both Aero and Glavel, using container glass are not carcinogenic. So of course, in our factories and in job sites, if dust is in the air, it's to be treated like any other dusty product as an inhalant irritant. But even on a job site, typically with putting down material and compacting it, it's not a particularly high dust environment. So generally it's not a significant problem from a even an inhalant or irritant perspective.
Yeah, and some of the factories I toured in Europe were really dusty, and some understood the importance of having, we can't have a dust-free foam glass plant, but really tamping down the amount of dust in the manufacturing process. So we are taking cues from the latter in setting up our production facility.
Travis, feel free to jump in because I'll just keep asking my questions if you don't say anything.
Yeah, I don't want to dominate the conversation, and I'm working the same list that you are, Emily, as far as audience questions. There are some good ones in here that I was certainly wondering. I think I know this one because I had it quoted for a project not long ago, but everybody wants to know the cost per pound, and everyone's going to say, yes, but shipping, because it goes to different places, it's going to cost a different amount regardless of how close you are to the, in observance of how close you are to the shipping facility. So let's assume that you were going to take it from your plant and hand it to someone who is going to drive away with it. Can you give us a cost per pound? And then people can figure out the shipping on their own.
Yeah, I think Archie and Glavel are right around the same range, that's sort of $75 to $80 per cubic yard. So we don't sell by weight, but by volume.
And that is a very favorable cost as someone who buys a lot of 3/4 crushed stone for backfill applications and other subgrade reasons. You are extremely competitive. It's the shipping that gets you. I think that I even quoted, I think with Glavel in the spring of this year, and the shipping was the only thing that pushed me over the edge. Otherwise, you guys are actually, I think you're actually cheaper on my project than my local crushed stone. So yeah, I think that's not really a stumbling block that builders need to worry about. You
Does
really
somebody
need
put
to
a plant in the Midwest?
I know.
You hear
come
that?
on over. We got plenty of room.
So
There you
Travis, that
go.
one of the things we wanted to, I mean, honestly, we haven't done a press release on this. We'll do it in January. But Teresa talked about the 3 facilities we have, Philadelphia, Florida, and in Northern California. We will be announcing 2 more facilities, one on the East Coast and one on the West Coast, in the first quarter to keep this footprint going. And we're getting to the Midwest. We're just not there yet.
We're not flyover country.
Yeah.
We're putting all kind of stuff out here. Come on over.
But
So
we
fingers crossed.
we do that, you know, we've had a pretty aggressive expansion plan, and part of that, a big part of that has been the logistics. I mean, we've shipped projects from Philadelphia to Oregon, Houston, Minnesota, and we've been able to make it work. But we believe the more we stamp out the footprint, the logistics get that much better and makes the whole system that much more cost competitive.
Yeah, when I researched it, I was shipping from Houston, and that was my closest opportunity. And that was really the only stumbling block. But I will tell you, we have local to Kansas City, Boulevard Brewing and another bunch of partners do ripple glass recycling, and a lot of it's recycled in, I believe, Oklahoma.
Yeah.
So there is material available to you.
Yeah.
I'm providing lots of glass bottles every Thursday night. I'm doing what I can. I want to do my part. Cheers.
We're working on raw materials every day we can, Travis.
Well said.
Oh my gosh. I want to go back to material content too, because we talked about the dust and the silica, whatever, but I was curious about the foaming agents. So it sounds like you use 2 different foaming agents, you know, from each of you. So it'd be really interesting to hear, you know, what is the foaming agent? Like, what material is that? What's that?
Yeah, so I mean, I can tell you about our foaming agent that we use for the closed cell material. It's a material called silicon carbide, or SiC for short. And we're actually sourcing, it's also kind of a recycled mineral because it's coming as a byproduct of the solar panel production process to us. And it's, you know, it's just a very fine, dry powder. So that's why we call it the dry process, because you're just mixing 2 powders together.
Yeah, and in our case, the wet foaming agent is a very commonly used industrial product, glycerin or glycerol. So it's an alcohol. So it's a source for CO2 under heat. So, you know, again, very simple and commonly occurring chemical.
Very cool.
I got to ask this one, since we've been talking beer bottles. Someone said, can we just throw beer bottles under the slab? I mean, if we're trapping air, that's an insulator. How many beer bottles? How many beer bottles before my clients think that I'm an alcoholic and not a reputable builder? I think is the issue with that. And Archie mentioned that earlier about the trash look of granular glass.
Yeah.
I think that would be the stumbling block there. But it's a legitimate question. Can you just put the glass bottles there? Do we have to foam them? I mean, they would fill up with water, right? If they're subgrade?
I think the foaming gives you the insulation properties versus the glass as a solid. So that's the first part. You know, one of the things when we started, it was Teresa and I coming back from a meeting in DC. We talked about how many tons of glass we recycle. And we realized that's very relative depending on who you're talking to. So we decided, you know, we need to convert this to a 12-ounce. I said beer bottle. I was told I could just say bottle, but I said beer bottle. So as a company, we're pretty proud to say next year to date, we will have diverted the equivalent of 500 million bottles from landfill. And with our 3 facilities, we'll be at 500 million every year. So we think that's pretty significant.
That's even more bottles than I'm using. So that's great. I really appreciate your efforts.
You didn't match that this year, Travis?
I can't do it. I got to step my game up. Even through the pandemic, I couldn't hit those numbers. Those are big numbers.
Yeah.
What about R value per inch? I thought somebody put in here R 1.7 or 1.8, but they wanted to ask about how that relates to compaction. So I would assume you have to compact the material regardless. Otherwise, it's not. I'm sorry. Go ahead. Answer the question and I'll shut up.
Yeah, the recommended compaction is 1 to 1.3, and our product is 1.7 per inch.
And with Aero, we're at a 1.25 compaction factor, and we have 1.67. So
And I think that's, go ahead, Emily.
I was gonna say, and to relate to that, I just saw this pop up in the chat. It says the aggregate size seems large. So what's the size of those? Like, is the R value really within those pieces, not in the material makeup of once it's compacted?
it's a combination. It's a combination of the particles and the airspace between them when you compact it.
Exactly.
And with this being the building science show, I know Teresa talked about one of the slides. I mean, I think one of the things that we're also excited about, other than just using foam glass as an aggregate, as an underlay under slabs, as an insulating layer, 100% foam glass aggregate. So now we have I'm not as strong as I look. So this is a lightweight cinder block that has insulating properties and better fire rating. And it's made from 100% foam glass, no aggregate in here at all.
Well, and those exterior panels were actually of some interest to me as well, because that's been one of the major stumbling blocks in below grade insulation in my market. We're termite country. And I know some builders in Lawrence, Kansas, where the University of Kansas is, that are very bright, and they've used XPS on the external slab edge and then had to wrap EPDM over it. But after seeing the ant farm, that's a little bit disturbing.
Yeah,
you're not getting much insulation out of those ant carcasses. I suspect the tunnels are low R value, isn't that right?
Yeah, and we're really excited to be able to bring the boards to market here in the US. So our goal is to have boards that can be cut dimensionally and service clients' needs depending on how they want to use them, either in that system, the RDS system that Glypor sells, but also as boards themselves. So
we can use it as the block itself, which Archie just showed us. We can use a board outside if we want to still pour inside. You can use it below the slab. I feel like this is one of those things that's just going to surround me.
Well,
In a
and
good
You guys
way,
making
though,
jackets?
right?
Like,
In a good way.
Well, and
Yeah,
I'm super
right.
curious too, because you're showing the block and then there's the board, but when you look at it, when it's coming out of your facility and it's like crushing it up into little rocks, it looks super fragile. So I'm like, my mind is trying to wrap my head around how all these different products work with the same
molecular
so in terms
magic.
in terms of the board, it's a similar but not the same process. So the boards have to be annealed essentially. So where we're making aggregate, you want the product to fracture and become an aggregate of varying sizes. With the board product, obviously you want to anneal that board in order to have a stable product. So it's similar but not exactly the same.
And Emily, to expand on that, so when you saw the video, what's neat about the process, the original crushing or cracking of the material is just the thermal stress. So the thermal stress puts it into the aggregate size pieces, and then that's when you look for your strength in those individual aggregate pieces. And there's a range of strengths depending on processes, but that's the initial process. You're shocking that, similar to taking a glass out of the microwave and putting it in cold water, you're going to shatter the glass. It's the same thermal process. So when we have contractors come through the facility, they're very disappointed because they want to see our crushing and screening operation, and they see it's all done naturally through Mother Nature.
We like big bangs. We want things to be loud and messy.
Exactly. Exactly.
No, actually, that's a pretty good point. The workability of the product is a huge benefit in my view. As I get older, I find that it's hard to push heavy things, or harder than it used to be. So raking all around or pushing with a push broom seems like a pretty big benefit. But it does tie back to that. You have to estimate your volume at that, 30% overage. So where, 3/4 crush, according to my local engineer, is like, oh, it's self-compacting. I'm like, well, okay, maybe in an engineering sense, but I still think it walks a lot different after I run the plate compactor over it. You just need to factor in that additional 25 to 30% yield so that you can adequately fill your subgrade and not run short.
Correct.
Yeah, exactly. And, full transparency too, we hear from contractors all the time that, there is a learning curve when they first run the compactor over the product. It's floating. How do they get used to it? It's not like 3/8, but they very quickly get it. So it's great to sort of see the acceptance curve and the shortness of time it takes them to go from what the hell is this? This feels, oh, I get it. That aha moment is really kind of cool. And we were installing the product out at our plant, and Ken got to see it sort of in real time. That acceptance curve was really kind of cool.
Yeah, and Travis, I'll add to that. You know, one of the questions, we do a lot of highway projects, and we use dozers and excavators to place and compact the material. So that was a big question for a lot of the DOTs. What's happening under the tracks when we're using this heavy equipment? And full credit to Teresa to work on developing a pretty high level method of showing exactly what's happening using LiDAR, a full LiDAR study that she worked with the university to show you exactly the compaction levels you're going to get depending on the size of equipment. And that was maybe a 2-year research project that resulted in design curves where you can actually design out exactly the level of compaction based on the unit weight, based on the lift thickness, based on the type of equipment you're running on it. So that's helped us quite a bit with the DOTs based on that report.
Nice. There was a question also, I think, was it Mason Lord that asked, what is the general size of the aggregate? Obviously, it's fracturing on thermal stress. It's not going to be uniform, but as a general rule, would you say that the lumps range from a 2-inch diameter to a 3/4 inch diameter? Give me a range.
Yeah, so nominally we say 3/8 of an inch to 2.5 inches, right? Allowing for about 15% under 3/8 and 15% over the 2.5 inches. But if you're looking for like a D50, right, the average size, we're right around 1.5 inches.
Nice.
I had one piece sitting on the windowsill, so you can get a sense of ours in my hands. That one's probably a little bit on the larger side of median. Archie, I have one of yours here too, so they're very similar.
Beautiful.
Yeah.
Yeah, I have a bag in my office, but I'm not in my office. So
yeah, and I should say, this being the holiday season and the color of our product, our friend Chris Corson in Maine a few years back asked for some gravel to use as coal in his son's stocking. So if you need some adjustment with your children and need a coal piece, just hit us up at Glavel and we can help you with some coal for the stocking.
That's a great idea.
Rob has us there. We're gray. We don't have it that color, so.
Well, you can be the snow, it's all seasonal.
Yes.
Yeah.
Let's talk about the bags. So I noticed when Ben Bogey was posting, our colleague Ben was posting about placing some of this material a week and a half ago. It appeared that they were cutting the bottoms of the bags open in order to do the placement. And I noticed that in one of the presentations, there was actually sort of a funnel already sewn into the bag. And that seemed like that would make the bag reusable, which seems desirable to me, but I also realize that there's shipping. And so maybe sending a bag back to you is a huge waste of resources. I don't know. Can we talk about the bags?
Sure. I think we've been doing a lot of projects, when we started further afield, and most of our projects we're using long haul, I call mulch trucks. And what makes the foam glass pretty competitive compared to other aggregates is we can get 90 to 100 cubic yards in a walking floor truck, where a dump truck holds about 13 to 14 yards. So you're getting 6 to 8 trucks in one truck with foam glass. So most of our deliveries we try to use in these bulk, but when they get a little bit further, or there's some customers that have some tight areas, we've used these large bags, and we've done everything from disposable bags, it's one and done, to the spout bags, and working on a more robust bag. And the idea there, Travis, is if you've got a large project that you're shipping a lot of trucks to, after so many trucks, one truck brings the bags back to refill to go back out. So we've done a combination of both.
Yeah, and we've only done the bags with the spouts, and the bags that we're sourcing for the Vermont plant will have the spouts as well.
But the bag comes back with the truck.
Yeah, I mean,
so
we're gonna, as I think as Archie just mentioned, we'll be working different loops, depending on the volume of bags going in different directions and then the customer's and certainly with the intention of reusing where we can. One thing that we'll have to certainly evaluate is, the integrity of the bag after multiple uses. So obviously we need to make sure that the bag they ship out is going to have, it's going to be reliable.
Yeah.
So to the extent that we can reuse, we will. To the extent that we can then get into, there's ways to send bags back for recycling back into new bags as well.
Just need to figure out how to turn the bag into the vapor barrier that you can just lay out over everything after you're done, and then pour your slab.
I like that idea.
Just to slice down the side, boom, lay it out.
Emily, you see everybody making notes now.
Wouldn't that be awesome?
Like, what's the permeability? We're gonna get all these questions about the permeability of our bags, and yeah.
Well, might not work in super wet areas, but it would be a cool idea.
Very cool idea.
Move over, Green Architects Lounge. That's Emily Montram with the 6-digit idea. Well done.
I got all kinds of ideas. Somebody else just has to do it and execute it and make it work, right? It's just a big picture.
Well, and I want you to go ahead and install we call it the gravel caster here. We have a few local firms that have the telebelt that'll fire the gravel, into your foundation for your fill. If the weight of your product could be thrown even further, if you could just go ahead and broadcast that from your plant to my foundation. You just got to dial that in with GPS, or maybe it's drones. Amazon can drop stuff off with drones. Drop me my product.
Travis, we've had 2 people tell us we should use blimps to bring it into a site. But on a serious note, we have done 2 projects with telehandlers, high-speed conveyor belts. One was in downtown Philadelphia underneath Chestnut Street, where we backfilled an arch to support it while they took the weight off of the arch. And before we did that, we did some trials at our yard, and we were getting about 50 feet with the foam glass. And the note was, the faster you went, the further you went, it was more of a shotgun blast, where the shorter and the slower you went, you could get more of a rifle approach. But we've done 2 projects with the telebelts.
Excellent.
So while we're still talking about bags and shooting it into the foundation, how many cubic feet usually do you get in a bag? And then how much does that weigh? Like, what kind of equipment do I need to pick this thing up off the truck and use it in my foundation, backfill, whatever?
Yeah, we were importing bags that were 4 cubic yards and about 800 pounds. And coming out of Vermont, we're going to be in that 3 cubic yard and about 600 pounds.
Yeah. And so our bags are maybe a little smaller than that. They're right around 3.5 cubic yards. And again, we make a little bit heavier of a product via the dry process. So it's about 1,200 pounds or so.
Yeah. All right. Have we exhausted the bag question? Do you have any more bag questions, Travis?
We can talk bag all day. What's in the bag? Where'd you get that bag? Does the bag match my shoes? Does my belt go with that bag?
Can I get my logo on that bag?
There you go.
So there were some other questions about the additional products and stuff that you use too, like the CMU block and the boards. Do they need to have a different finish or surface on them to be used as exposed to the weather or anything? Like, obviously in the aggregate, you want the water to move through it, and but is there any kind of issue with exposure or water on those exterior elements?
So for us with the CMUs, we're running pilot runs right now with 2 different block plants. And what we're finding is there's kind of 2 thoughts on this. One is the standard CMU, which is the one I held up. And then there's another one where we introduce more fines and you get a smoother surface. So if you're looking for a painted surface block, that's going to incorporate a little bit more of the fines. If you just want the lightweight insulating block, it's going to be a rougher surface, but you're going to have better insulating values and a slightly rougher surface. So that's what we've seen with ours.
And Glideport can recommend either a paint sealant for the outside of the Glideport boards, or adhesive so that you could put faux brick or stone if it's a foundation application that you want it to look like. If you want to, Travis, I'm not saying you have to, the client is always right.
Yes, I've heard that.
So if they want to have that sort of look, it can be achieved.
And I think, you know, it's worth saying too, with the CMUs, what we also look at is the logistics. So having 5 facilities across the country, we can actually work with local block manufacturers. So the freight on the finished CMU will also be a regional thing as much as it would be, you know, anything else.
Since you're using the annealing process to make those CMUs or boards, can you just go ahead and stamp the look of that fake stone in there so that it can only be single level fake and not double level fake? Like just one application. I'm all about cut and labor. You know, if you can just press a line into that creates sort of an irregular form. I don't know. I'm always.
I'm happy to ask Walter. What I've always been struck about Walter Frank at Glypor was the degree that they cater to what the customer wants. You know, one manifestation is they've got a pretty wide variety of foam glass that they offer in terms of density and R value. The other is the dimension by which they sell the boards. So I wouldn't be surprised if Walter said, yeah, we could figure out a way to stamp the outside of the boards to give you that faux look. That's just how he's wired for sure.
I like this, Walter.
I don't want to burst the bubble, Travis, but the boards are more like bread. You bake it and then you cut the crust off to get it the shape.
Oh no!
Sorry.
Sure.
I eat the crust. I don't throw it out. It's okay.
Maybe they can just like 3D print it on there for you, Travis. So it'll look super fake. You know, it's be like an image of it flat on the surface, you know.
All right. Somebody, let's get back on track here. I'm sorry. I didn't mean to derail us.
Totally derailed it.
Yeah. How about compressive strength? Somebody asked about the compressive strength, PSI, anyone?
So we, you know, this is where we probably differ in thought process. We see what's available in the market today, the European experience. The dry process has a confined compressive strength. It's 2 to 3 times higher than the wet process. So for under slab applications, we don't see a big deal. When we see retaining walls under roadways, that's when we see a significant difference where you need the higher compressive strength.
So
yeah, we think those numbers are a little high in terms of the compressive strength, but it also has to do with the different testing methodologies in Europe, how you measure that and how you compare it to, say, foam board and what tests you use to compare the product with. But as Archie said, in applications where it's under a slab, compressive strength really isn't an issue. It's going to be much greater than foam board.
So in relation to that too is, you know, lots of people are working on using a replacement as an aggregate. How viable is it as a concrete aggregate? I saw what looked like, and now I don't remember whose image it was, but you know, so it looks like the mystery meat in Italy, you know, where the gravel is. If you haven't been to Italy and you haven't seen it yet, then you don't know what I'm talking about. But that's what it looks like as an aggregate in the concrete.
Emily, you're right on the money. It's the gelatin with the little nuggets. So,
yes. Oh, you knew what I was talking about.
Yes. Yeah. And we call it mystery meat too.
Yeah. Well, I mean, I'm sure it has an Italian name, but.
So we have a couple patents pending on the use of foam glass as a aggregate replacement for lightweight concrete. And without a doubt that's a great example of compressive strength has a huge impact because foam glass is weaker than an aggregate. So the higher strength the foam glass, the higher break strength of the concrete. So Treese is finishing up a program where we're able to get concretes down to 90 pounds per cubic foot, 90 to 100 pounds per cubic foot with compressive strengths 3,500 to 4,000 PSI. And what we think is neat about that, in addition to the CMUs, is a lightweight concrete that also has insulating properties built into the concrete because of the foam glass within the concrete.
Do the aggregate pieces have to be smaller in that application? Like, do you have to just, yeah, okay.
Yes, they do.
That makes sense.
What was our other, there was another bold-faced one there, Emily. Was it it wasn't the weight. We kind of talked about that per bag. Well, maybe we didn't. Do we have like a weight per cubic foot.
Right. So we're the dry process, right? We're at a maximum of 15 PCF dry bulk unit weight. So you know, what your delivered unit weight is really depends on kind of how long the product's been in our stockpile and if it's been rained on, snowed on, whatever, and how much moisture it has sticking to the surface. But in terms of dry unit weights, you could expect, you know, a maximum of 15 PCF. And really on average, we're right around 13 and a half in what we make.
Do you see this used in gabion walls at all? We use a lot of gabion baskets for drainage channels and other retaining wall applications. And it would seem like the guys on my public works crew here locally would prefer not to lift heavy things. Just putting that out there.
Yeah, so where we see that, these are good questions. We actually have one of our other patent pendings is to use foam glass in a gabion wall as a sound wall. Because of that porous surface, we actually, unlike a concrete sound wall, which will bounce the sound off, the porous structure of the surface actually absorbs the sound. So we've got one in to use its facing of complete gabion replacement with foam glass, or just the facing of a gabion wall, especially around areas of rail tracks where you have a lot of screeching of the tracks going around bends, to face the gabion walls with it.
Yeah, you can see those applications in Europe with the sound walls already using foam glass in that application.
Yeah, but certainly a lot of gabion wall applications, right? They are deriving the resistance of the wall from the weight of the aggregate on the inside of the gabion. So if you need that, foam glass probably would not be the best rock to use.
That's fair. Do you all have environmental product declarations for these products? And would you be willing to share a link to those in the chat for those people that want to do the deep dive?
So we're partially through our LCA right now. So our EPD is still a ways off, but that'll be something we'll see next year.
Nice.
I think, well, Teresa, you could probably answer. You need about a year's worth of production experience to put them out. So you probably get a hint here that Teresa does a lot of heavy lifting at Aero Aggregates. Teresa's been working on the LCA, so we're hoping to have an EPD later next year.
Yeah, and we're gonna, obviously, once we start production, we'll start the process for our LCA as well. So
Yeah, and I appreciated you talking about that, you know, some of that stuff.
We do have Glidepore's LCA, so you can at least have a frame of reference in terms of what an EPD would look like for foam glass. And again, since we're manufacturing using carbon-free electrons, it's just going to be better.
We do the same, right? We can point you to folks in Europe that are manufacturing via the dry process that do have established EPDs.
Excellent. Well, we're kind of toward the end of the show now. And so we like to give everyone a chance to do, you know, any final thoughts, something that you wanted to share, but we never asked you the right question, something ridiculous that we wouldn't have asked you anyway. Go ahead and throw that in. But this is the end of the show. We really appreciate your time. I want to thank you for joining us and helping us to educate our viewers, and certainly educating me on the topic. So how about it? Rob, you got anything that we didn't get to?
Yeah, no, I think just the fact that it's an exciting time to be in the foam glass business and having such amazing groups and ecosystems around high performance buildings, and being able to meet demands for their buildings with a product that's that much better for the environment is just, you know, just really, really excited to be a part of it.
Yeah, for sure. How about you, Ken?
I think Rob summarized the foam glass part well. I promise to report back on the Noble Bright. It's just about done. Good choice for the night. I recommend it to anybody when you get up here.
That's the technical data that our viewers tune in for. I appreciate the follow-up, Ken.
Yeah, I mean, really, honestly, 90% of them are here for the beer, and like 10% of them are here for the knowledge. What, you know.
We'd love to show off the facility to anybody that's going to be in the area. We're in Essex, Vermont, which is just outside of Burlington. And our sales and, you know, headquarters office is in Burlington, Vermont. So, you know, we too have plans already underway for the next facilities. So those announcements will be coming as well. But for right now, it's all about getting number one up and running, which should be in early February.
I just realized one thing, Ken, that we didn't talk about, and the fact that our plant is located right next door to Saxon Hill. So mountain bikers that are out there, come visit us in the summertime, get some mountain biking in, and come check out the facility.
Nice. How about you, Archie? Do you want to share anything more? Because I know that Teresa's going to be the high point. So you got to finish
the other way
strong.
fast. I agree. First off, it is fun doing a webinar podcast with the beer, because we do a lot of them, but we don't get that beer doing most of them. No, there was a lot of questions about, where's the material available? We're pretty fortunate. We have a lot of projects going in across the country right now. So I know this goes out across the country. If anybody has any interest of seeing one going in, Bangor, Maine's going in over the next couple of weeks. We have jobs in Philadelphia. We're doing a hospital in Orlando right now. So if there's any interest, actually, it's a lot different. And I think Rob mentioned earlier, seeing the material going in and getting a feel for that. Just let us know. We can point you to different projects in different parts of the country if you want to check it out.
Yeah, I guess I'll finish.
Please.
All right. Well, I guess I would just like to end with encouraging anybody that has any questions about foam glass aggregate to, not hesitate to certainly reach out to us. We're coming up now on 5 years of manufacturing, and I think I've been through everything that's been written about foam glass aggregate since it was created. So, I'll do my best to answer any questions that anybody has. And if you do have projects, even if you think it might not be kind of a cost-effective proposition, as Archie said, we've bid projects all over the country now, and we'd be happy to look at one of your projects and see if it is an option for you.
Awesome. So thank you all so much for your time. It is great to talk about new products and how we're changing and moving towards a better carbon future. It's awesome to have all of you here. I appreciate you taking your time. It's clearly great to have a bunch of really technical experts who can answer all of the crazy questions in the chat box where I'm like, I don't know. So thank you. Really, we appreciate your time and sharing it with us tonight on the show. This will be up on YouTube as well. So you guys feel free to share it with anybody who has questions about it after the show. So thank you for your time. Have a great evening.
Thank you.
Thanks, everyone.
Thank you.
Take
Thanks
care.
so much. Cheers.
Cheers. Bye-bye.